Today I want to prove the sine angle addition theorem. So let's get started. Our first step is we want to realize, what are we actually proving? Well, we're proving that sine of x plus y equals to sine of x times cosine of y plus sine of y times cosine of x, all right? Now, how should we actually do this? Well, the first thing we want to do is let's start with sine of x plus y. All right, and let's go down here and let's look at this shape right here. Well, sine of x plus y. We have these angles here. We have angle x and we have angle y. All right. Now, if we just look at the triangle I'm going to shade here in green, all right, this is going to be triangle AFD, all right? So that triangle includes these two angles. If we take a look at what is the sine of these two angles, well, sine is opposite, right? So opposite is going to be DF over our hypotenuse. Our hypotenuse in this case is just 1, right? So we can say that the sine of x plus y is equal to D line segment DF. So let's write that down. Then we want to break DF down into another part. So what can we say DF is equal to? Well, we can say it's equal to DE plus EF. So line segment DE plus EF. All right. Then I want to change this one more time. We're going to keep DE, but what can I say EF is equal to? Well, if we look at this shape, we can say see that EF is part of a rectangle, right? And since it's part of a rectangle, the opposite side to it is going to be equal. So here we have EF, right? That means that CB is going to equal it. So we can say that this is equal to line segment DE, like before, plus line segment CB. Then, which is our next step B? Well, what we want to do is we want to start labeling bits of our triangle. Of our shape. So the first thing we want to do is let's just turn this into the triangle I'm going to shade in blue. This triangle I'm going to shade in blue is triangle ACD. So this just has our x angle now. So what should we say the sine of our x angle is? Well, we can say the sine of our x angle, that's opposite, is DC, line segment DC, over the hypotenuse. But in this case, our hypotenuse is 1, right? So we can just say that sine of x is equal to DC, right? So I'm just going to label up here sine of x. Then, what can we say about cosine? Well, the cosine is line segment AC over the hypotenuse. The hypotenuse, once again, is 1. So we can say that line segment AC is equal to cosine of x. All right? So then, let's take a look at, let me grab a red. Let's take a look at this triangle. I'm going to shade in red. So this triangle just has angle y. So what can we actually say about it? Well, the first thing we want to do is let's do the sine of it. Well, the sine of it is let's write it down. Sine of y, right, is equal to, well, opposite is CB, line segment CB over hypotenuse. In this case, we already solved. Our hypotenuse is cosine of x, right? So cosine of x. Then we can multiply both sides by cosine of x, and we get line segment CB equals sine of y times cosine of x. So see, we've already figured out the CB part of this. Now we just need to figure out what DE equals. So here we have DE up here. All right, and this one is a little bit trickier. So what you need to realize is, hope maybe you know this already. It might be hard to see though. Y, our angle Y, is equal to this angle up here, right? This angle right here. So this is Y, and then this whole angle is 90 degrees. So we can say this angle here is 90 minus Y, right? This angle here is 90 degrees. And then we can say up here, this is Y. And why can we do that? Well, 90 plus 90 minus Y plus Y equals, 90 plus 90 equals 180. The Y's cancel out, 180. All right? So we can say that this is Y. Now, what we want to do is figure out the cosine of Y. Why are we doing cosine in this case? Well, we're doing that because cosine incorporates side DE, which is what we're trying to solve for. So cosine of Y equals, well, we have DE, right? Line segment DE, because that is adjacent, over the hypotenuse. In this case, the hypotenuse is sine of x. So we can say line segment DE equals cosine of Y times sine of x. Now, let's come back up here. We already know that sine of x plus y equals line segment DE plus CB, right? Now we can change out these, DE plus CB, with sine of y times cosine of x and cosine of y times sine of x. So at the end, we get sine of x plus y equals, well, DE equals cosine of y times sine of x, then plus CB. Well, we know CB equals sine of y times cosine of x. Right? This is the same thing as this. Now, thank you for watching. Hope you have a great day. Let me know if I said anything incorrect or if you want to add on to anything. Thank you.